In this video, let's review some derivatives. Let's start with the average rate of change. Of course, this is just our slope formula. If we want to find the average rate of change of a function, f of x is x cubed plus 1 over some interval, we just need to evaluate the function at each of those endpoints of the interval, and then just using our slope formula, so our y2 minus our y1 over our x2 minus our x1, and that's going to give us just 19. Now the instantaneous rate of change, of course this is our derivative, is the derivative evaluated at that point. So if we're given a function, f of t is 2t squared plus t minus 7, we want to find the instantaneous rate of change at a time of 4, let's find the derivative of the function. And so this is just our power rule. So multiply the exponent times the coefficient, 2 times 2 gives us the 4. We subtract 1 from the exponent, so that's just 4x. The derivative of t is just 1, and the derivative of a constant is 0. Now we take that derivative and we evaluate it at that time of 4. If we plug 4 in for the x, that gives us 16 plus 1, or 17 miles per minute. For an equation of a line tangent, we're going to use our point-slope formula. That means we need a point and a slope. What is the equation of the line tangent to this function at 1? So first, let's evaluate the function at 1 to get that point. If I plug in 1 into my function, that's 3 times 1 minus 2 times 1 squared. That's going to give me a y value of 1. So I've got the point 1, 1. Next, we need a slope. So let's find the derivative of that y. Well, again, using our power rule, 3x the derivative would be 3, and using the power rule on the second term, 2 times the negative 2 gives us the negative 4, and when we subtract 1 from the 2, this is just a first degree. All right, so here's the derivative. Now evaluate the derivative at that x value. If I plug in 1, 3 minus 4 gives us negative 1. So now I have a point and a slope. We can plug that into our point-slope formula. So it's going to be y minus 1 equals our m value, which is negative 1, times x minus 1. And it wants us to approximate f of 1.01. So I'm going to plug in that 1.01 for the x value. And when I do a little arithmetic, I end up with y is equal to 0.99. Now, this is an overestimate because y is concave down at x equals 1.01. So a couple of ways that you know it's concave down. First thing, if you recognize this function, that's just a quadratic. Our leading coefficient is negative. So it's some parabola that is just opening down. Now the other way you could identify that it's concave down is using our second derivative. If I were to take the second derivative of our function, okay, so the derivative of the constant is 0, the derivative of negative 4x would be negative 4. So if your second derivative is negative, we know that this is concave down. All right, so if ours is a concave down function, we know a tangent line is always going to be above the function. And so it is going to be an overestimate because the y value is concave down. A function is differentiable if it is continuous and differentiable at every point. We have no holes, cusps, corners, or discontinuities. If a function is differentiable, then it is continuous. If a function is continuous, then it's not necessarily differentiable. Let f be a function such that the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h is 5. So remember, this is the definition of the derivative. We know that an x value of 2, our derivative is 5. So if a function is differentiable, then it's continuous. So because this has a derivative at 2, it is continuous. So f is continuous at 2. It is differentiable at 2 because we see that the derivative is 5. Do we know that the derivative is continuous? That is not true. We don't know anything about the derivative. Next up is the product rule. The product rule is the first times the derivative of the second plus the second times the derivative of the first, and that's when you have two factors, like this example here. So we'll have the first factor times the derivative of the second plus the second factor times the derivative of the first. When we clean this up, FOIL them together, we end up with this. Quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And so we can see the bottom term is 3x squared, so there's your bottom. Derivative of the top, if we just do your power rule, that'll give you 8x minus 5, minus the top, the whole entire top, minus times derivative of the bottom, which would be power rule 6x, divided by the bottom squared. You are perfectly fine to leave it like this. You do not have to simplify, but if you wanted to, there are some options. Chain rules when you have a composition of functions. And so here is what the derivative is. It's the derivative of the outside with the inside function times the derivative of the inside function. And so in this case here, our outside function is just x to the fourth. So the derivative of x to the fourth would be 4x to the third times the derivative of the inside function. And so here it is. If you wanted to clean it up, here would be your option. All right, the derivative of the outside function using the power rule, that would give you negative 3. Here's the inside function raised to the minus 2 when we subtract 1 from the exponent times the derivative of the inside function. And again, it's perfectly fine to leave it like this. Some trig derivatives that you'll need to know. Derivative of sine is cosine u. Derivative of secant is secant tangent. Tangent is secant squared. Cosine's negative sine. Cosecant is cosecant cotangent negative, and cotangent's negative cosecant u, squared u. Here's how I remember these. If I can just remember secant, secant, tangent. Cosine and sine, I have no problem remembering. It's these that I can't remember. But I once, I found a video trying to like strategies in remembering them. And if you can just remember secant, secant, tangent. So the derivative of secant is secant tangent. The derivative of tangent is secant squared. Now, for cosecant, it's similar. These are just like your sister functions here. And so, but there is a negative on this middle cosecant. So the derivative of cosecant would be a negative cosecant cotangent. The derivative of cotangent is a negative cosecant squared. And that's how I remember what these four are. All right, so when we're finding the derivative, we have sine 2x cosine 3x. Of course, we have the product rule with the chain rule. And so this is first times the derivative of the second with the chain plus the second times derivative of the first with the chain. And you can just leave it like this. We have the quotient rule here. So it's bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. Leave it. In the third example, we have cosecant times cotangent. So this is the product rule, first times derivative of the second plus the second times derivative of the first. And in our last example, secant squared 7x. So rewrite it with the squared on the outside. So now we can see this is trig derivatives plus chain rule. So if I bring that 2 out front, here's the inside function, and it's going to be to the first. We subtract 1 times the derivative of the inside function. And this is actually has two compositions because your inside is 7x. So the derivative of that would be 7. So this would be your final answer. For inverse trig, tangent, here's how I remember this. Tangent's a plus sign, so it's a plus u squared. Sine, subtract, so I know there's a minus sign there. And it's also s for square root, so square root and subtract. Okay, so the derivative, y is equal to tangent inverse of 8x. So we're going to have our u value be the 8x, or our inside function be the 8x, and so then it's times the derivative of that inside function, and I would just leave it like this. And our u in this case is 5x minus 1, so here's 1 over square root of 1 minus 5x minus 1 squared times the derivative of the inside function, and I would leave it like that. The last couple of derivatives, an exponential, of course, is itself. How nice. Derivative of natural log is the reciprocal function, 1 over u. Here's one that we need to add. This is the derivative of an exponential. A to the x is natural log a times a to the x. You might see this on your test. It's very rare. That's why Mr. Sassman left it off, but occasionally it will be there, so might as well have it. All right, so here's our example. We have quotient rule with e to the x and natural log. So it's going to be bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. In the next example, we have a composition function with e to the x. So the derivative of e to the sine 4x is just e to the sine 4x times the derivative of the inside function, which would be cosine 4x, times the derivative of the inside function, which would just be 4. I would leave my answer just like this. And the last example, we have product rule with chain rule. So this is first times derivative of the second with the chain, plus second times derivative of the first, and that's it.